Hello everyone. So I'm Rahul Kaushik and guys I welcome you all on Unacademy's JEE English. So guys today I'm going to teach you chemical bonding lecture number 10 and today I will be covering hydrogen bonding. As you know hydrogen bonding, yes, something very important, something related to water and it comes in day-to-day life. So what is hydrogen bonding? How many types of hydrogen bonding is there? What are the consequences of those types? Suppose we have intermolecular, intramolecular. So we are going to discuss each and every point today. And along with those points, I will also tell you guys what are the conditions that are necessary in order to have hydrogen bonding. Okay. So hydrogen bonding, as you know, hydrogen bonding is a very important topic, and almost every year there is a problem over it, either in JEE Mains or in advance. So guys, listen me carefully whatever I'm saying. And before starting it, let me give you my brief introduction. So I'm Rahul Kaushik and I worked in Bansa classes Kota for continuous 10 years. And during my tenure there, I was head of department and I mentored 2000 plus IITs. Yes, 2000 plus IITs. And after that, I co-founded my own organization, that is Zigyan Education Private Limited. And now along with Zigyan guys, I'm here on Unacademy, India's largest and fastest growing online platform, right? So the purpose of this JEE English channel, yes, on this channel we teach each and every concept of IIT JEE in pure English, right? So on JEE English, we are here just to provide you the free of cost education, and that will be especially for those students who are facing issues with the Hindi. Okay, guys. So this is a brief introduction of this channel, and this is our Telegram link. You can join our channel on Telegram. Yes, and the link for this channel is given in the description part of this video. Okay, guys. So you can hi nothing peace. So the link for this channel is given in the description part. You can directly click on it, and you will be subscribed to that channel. Okay, just a minute. After that, now let me tell you what are the simple steps how you can subscribe to Plus. So just go to Play Store or App Store, download Unacademy's learning app, not educator app, Unacademy's learning app. Once you download it, install it guys, and after installing it, yes, you will be directed to this page. On this page, when you click on the plus, you will be again directed to this. So you have to choose your goal. Suppose you are preparing for IIT JEE, then choose IIT JEE as your goal. Once you have chosen IIT JEE, then hit the subscription button, right? So after hitting the subscription button, you will be directed to this page where you have to choose a program for 12 month or for 24 month. Okay, nothing please, I will discuss, don't worry. During the class today I will discuss, I will take up your query. Surely I'm going to take up. So okay, nothing please. So guys, for 24 month and 12 month, these are the main programs. If you are serious about IIT JEE or NEET preparation, NEET UJ preparation, then you have to join it at least for a year, for 12 month or for 24 month. Hi Ashish. So if you are applying my code, then what advantages you are going to get? Now let me tell you. For 1 year the fees is 38,000. For 2 years the fees is 56,000. But if you are using my code Rahul Kem, then instead of 38,000 you just have to pay 34,000. Instead of 56,000 you just have to pay 50,000. Got it? So just remember this code. This is my code Rahul Kem. If you are applying this code, then you will be getting this discount. Okay, so what are the benefits? So now I will tell you the benefits of Plus. So the course on the Plus will be structured. So on the YouTube we are just providing you the video lectures, but on the Plus, along with video lectures, we will also be providing you the modules, DPPs, sheets. So you will be getting their DPPs and modules as well, right? After this guys, yes, you will have live quizzes there, and after completion of every topic, you will have mega quizzes. After completion of every topic, you will have mega quizzes, right? So these are some benefits. Now I'm going to tell you the most important point, and that is every fourth class will be doubt clearing session. So once you are on the plus, you will have no doubts at all. Every fourth class will be a doubt clearing session. You can ask any doubt, and that is compulsory. And then you will have access to the test series. Yes, that the test series conducted by an academy. So you can be part of the test series because when you're preparing for technical exams like NEET UG or IIT JEE, then you should have a very good paper temperament. Because I have seen so many students. I've seen so many students like they know everything but they cannot attempt paper very well. For them, yes, test series is the best way to develop your paper temperament. So you will have access to the test series conducted by an academy. And the important point is, if you are planning to join a test series, then you should go for a test series where every kind of papers are there, like topic test, part test, and along with those guys, number of students should be very high, so that whatever percentile you are getting in the test series, almost you should have that idea that almost the same percentile you are going to get in the main exam, the final exam. Okay, so that's why I generally suggest this. So this is all about it. Now let's start it. So before starting, let me take up the query. Let me take up the query from Nothing Piece. Sir, can you please tell the important topics or important topics lessons for mains? So I will tell you. I will tell you the important topics. First of all, every topic is important. First of all, every topic is important. You should not miss anything. I generally suggest you to go for the topics which are must. Now, every topic is important. Every topic is important, but you should suppose that if you are talking about the chemistry in physical without mole concept and gaseous state, or we call it state of matter, you cannot do anything. And in inorganic, yes, periodic table, chemical bonding, this is must. Actually, these are the fundamentals, these are the basics. If you don't know anything about these topics, if you don't know anything about these topics, then guys, you cannot study chemistry at all. So Nothing Piece, hi BNC, hi. Now you can say bye. So I was discussing something, like Nothing Piece was asking something. I'm just telling you that every topic is important. You should not be blank about any topic. You should have basic. Hello guys, am I audible? Please confirm me. Am I audible now? Please let me know. Actually, there seems to be some issue with it. Let me check it now. Am I audible now? Yes, now I'm audible. Yes, yes, I'm back. So let's discuss it again. So just look at this diagram. Just look at it. So when we are talking about it, yes, now this issue has been resolved, guys. So when we are talking about it, now let me tell you one more point here. So we have, okay. So now let me take we have carbon, kahe Sita ji suno prabhu, and then we have newspaper आज सब बिकेगा उससे टीपो. I hope guys you got it. Similarly, we have fluorine, chlorine, bromine, iodine, and astatine. Why I'm taking these? Why I'm taking these? So in this case, it will be forming HF, HCl, HBr, HI, and H. So we do not talk about it. CH4, SiH4, and similarly SNH4. So when I'm talking about this is NH3, this is PH3, ASH3. In this case, I'm getting H2O. In this case, I'm getting H2S, H2SC, H2T. I hope guys now you got it. Got it? So when I'm talking about it, just observe as we move downward, the molar mass increases because H is common. Chlorine, chlorine, bromine, iodine. So molar mass is increases. So normally the boiling point is directly proportional to molar mass or surface area. So as size increases, I can say the boiling point will also increase. Got it? So these are the points I'm talking about. So it is specifically for the boiling point. I will discuss how it depends upon the surface area when I will teach you about the basics of weak forces, the van der Waals forces, dipole-dipole interactions, dipole-induced dipole interactions, hydrogen bonding. We are already doing it. So when I will be teaching all these forces, then I will be discussing in detail. So boiling point is generally directly proportional to molar mass. So as molar mass increases, boiling point also increases. So why I'm talking about it? Why I'm talking about it? So as per my theory, boiling point of HF should be lower than HCl, then HBr, then HI. Similarly, boiling point of H2O should be lower than H2S. So it should be the order. Similarly here, got it? But guys, just observe it carefully, but order is not the same, right? So what is the order? If you observe about the boiling point, just observe it. So when we are talking about the boiling point, yes, pH3, ASH3, and SBH3, boiling point is increasing. But ammonia, the boiling point of ammonia is maximum. It is more than all these three. Similarly, HCl, HBr, HI, boiling point is increasing. But why HF? HF should be here, but it is here. Why this is so? Why this is so? And what is the reason behind it? What is the reason behind it? So what would you say about it? What is the reason behind it? So why these graphs are like it? Actually, as per my expectation, these graphs should be ammonia should be here only, and this HF should be here only, and this H2 should be here only. But why they are very high? It means there must be some forces in H2O, HF, and NH3, and due to that force, their boiling point is very high. So what is that force? Now I will start from here. And why only for these three? CH4 is okay. CH4 is okay. So why this is so? Can you tell me now? So why this is so? So now I will tell you guys. Now I will tell you. Yes. Normally melting point and boiling point are directly proportional to molar mass. But when we are talking about these three, H2O, HF, and NH3, their molar mass is least in their group, because if I compare NH3 with PH3, the molar mass of it is less, but its boiling point is highest. H2O's boiling point is highest. So what can be the reason? So the reason behind it, yes, there must be some force. And what is that force? Now I will discuss that force. Why this compound exists? Actually, it will give you K plus and HF2 minus. This is ionic compound. This is ionic compound. Why this is ionic compound? Because a metal is involved. So why? What kind of compound is it? So I will tell you, this is HF. We have F2 minus. So what will happen? There will be some F minus and that will interact with it. Why I'm making it dotted? Why I'm making it dotted? I'm telling you, this is the force of attraction. I call it hydrogen bond. And as a result of this hydrogen bond, what will happen? What will happen? Now I am getting, yes, HF2 minus. So due to the hydrogen bonding, it is negatively charged. So it will combine with K plus. So it will combine with K plus. So there is some force of attraction between F and H. And I hope you remember it. Just in the lecture 1, when I discussed the chemical bonding, I told you that when a chemical bond is formed between A and B, the amount of energy released will be greater than 42 kilojoule. It will be greater than 42 kilojoule. And if it is 8 to 42 kilojoule, so we categorize it 0 to 8, 8 to 42 and greater than 42 kilojoule. So if it is greater than 42 kilojoule, then I will call it chemical bond. Then I will call it chemical bond. If it is between 8 to 42 kilojoule, then I will call it hydrogen bond. So when hydrogen bond formation take place, yes, the amount of energy released will be 8 to 42 kilojoule. And when you want to break that hydrogen bond, again you have to provide the energy between 8 to 42 kilojoule. That's why they have high boiling point. Because what is boiling? In boiling, yes, you have a liquid and you are evaporating that. That liquid is getting converted into vapors, right? So when you are evaporating a liquid, these liquid particles are evaporating. These are leaving the liquid surface. So when these are leaving the liquid surface, what will happen? Yes, because of hydrogen bonding, you have to provide larger amount of energy. And if you are providing larger amount of energy, then guys, I can say that its boiling point will be higher. So hydrogen bonding exists. Hydrogen bonding exists in HF, H2 and NH3. That's why they have very high boiling point, but it does not exist in CH4. So now point arises, why there is hydrogen bonding in these three, but there is no hydrogen bonding in CH4. So is there anyone who can tell me? Now what can be the reason? Now we will look for it, but now you know the reason. Why? Just a minute. So now you know the reason why H2O is having higher, why H2O is having higher boiling point than H2S and H2SC and H2, right? Your order is different than what you expected. Why it is different? So as per expectation, why HF, why NH3? But CH4 is as per expectation. Yes, this is increasing as molar mass is increasing. So in case of these three molecules, there is hydrogen bonding, and because of that hydrogen bonding, you have to provide extra energy to evaporate that liquid. So we call that they will have higher boiling point, right? So I just discussed with you what is KHF2. This is ionic compound, and again HF, this is covalent compound, and 1F minus will form a dotted dotted. So this is forming the hydrogen bond I have already discussed. So due to this bond, yes, I can write it as HF2 minus and it is K plus. So when they are mixing, they will be forming the ionic bond. Got it? So many times you might be asked that why this compound exists, but this compound does not exist. Why? So you will say, yes, there is hydrogen bonding that is possible here, but that hydrogen bonding is not possible here. No hydrogen bonding is possible in this case. In inorganic, yes, the problems are made only like this. If you know the basics, then you can solve. If you know the basics, guys, then you can solve. Got it? So now I'm moving ahead. So what is hydrogen bonding? So now you can, again I will show you HF and F minus and this. So this is the attraction, and due to this attraction I have told you that because of attraction there will be always energy release. Due to this attraction there will be always energy released. And due to release of this energy, yes, suppose the energy release is 20 kilojoule per mole. So when you will be breaking this bond, you have to provide the 20 kilojoule. And for hydrogen bond, for hydrogen bonding, the energy release will be of order 8 to 240 kilojoule per mole. Right? So what is hydrogen bonding here? What is hydrogen bonding? So it is electrostatic force of attraction. This is attraction between hydrogen and more electronegative element, fluorine, oxygen, nitrogen and chlorine. Yes, not always chlorine, not always, normally with three elements: fluorine, oxygen and nitrogen. Got it? So and this bonding, this attraction is known as hydrogen bonding, and energy released is between 8 to 42 kilojoule. Got it? So we divide forces between three parts. Yes, weak forces, hydrogen bond and chemical bond. Right? If energy release is 0 to 8 kilojoule, then it is weak force. 8 to 42 kilojoule, then it is hydrogen bond. 42 kilojoule or greater, then it is called chemical bond. So we have these three types of forces here, and we divide. So in hydrogen bond, again I'm telling you, yes, this is HF, this is F minus, so this will be the positive and negative, but this is partial positive, this is partial negative. Why? Because of electronegativity difference. Fluorine is more electronegative, so it will attract the shared pair of electron and will get partial negative charge, and hydrogen will get partial positive charge, and due to that you will be getting F minus. Got it? So this type of attraction is called electrostatic attraction, and normally hydrogen bonding, obviously there must be hydrogen and it should be between F, O, N, sometimes with chlorine as well. So I hope now you got the idea what is hydrogen bonding. Got it? So let's move. Now I'm talking about HF, H2O and NH3. Yes, in HF we have hydrogen bonding in solid, liquid as well as in gaseous phase. In water we have in solid and liquid. No hydrogen bonding is there in the gaseous phase. Means in steam there is no hydrogen bonding. In ammonia again, in gaseous state there is no hydrogen bonding. So hydrogen bonding is there in solid, liquid and gas. So now my point arises, yes, what are the factors on which hydrogen bonding depends? Can you tell me? What are the factors on which hydrogen bonding depends? Because in HF we have hydrogen bonding, in H2O we have hydrogen bonding. Now I will discuss when I'm talking about the HF. So this is partial positive, partial negative. This is partial positive, partial negative, partial positive. Okay. So when this hydrogen having partial positive, yes, it can interact with F minus. So the force of interaction will be K Q1 Q2 by R square. So larger the charge, larger the charge, larger will be the force of attraction. And how large charge will be generated? Can you tell me? So similarly here, if I'm taking another H2O, so this delta positive, yes. So out of fluorine and oxygen, which one is more electronegative? So you will say that oxygen is more electronegative. And if oxygen is more electronegative, sorry, fluorine is more electronegative, so the charge developed at this point will be more. So I will say that HF, the hydrogen bonding in HF will be more strong. Hydrogen bonding in HF will be more strong. Got it? So that's why even in gaseous phase there is hydrogen bonding. But in H2O and NH3, there is hydrogen bonding only in solid and liquid phase. So how that hydrogen bonding will take place? This is H2O. This is H2O. This is H2O. Now if I talk about this, so it is delta negative. Delta negative will be delta positive. So this is the hydrogen bonding. Similarly, you can show a hydrogen bonding here as well. If I talk about NH3 and this, so it will be delta minus. So again there will be force of interaction between them. So which bond will be stronger? Yes, write down in the chat box. If I ask you which bond will be stronger, is it bond 1? Okay, you can't see it. Is it bond number 1 or 2? Which bond will be more stronger? Yes, can you give me idea about it? Anyone? So again, what is the order of electronegativity? Fluorine, oxygen, nitrogen. 4, 3.5 and 3. So oxygen is more electronegative. So the charge developed here will be more. And if charge developed is more, so one will be stronger than the two. And now you know the reason. Similarly, if instead of it there would have been HF, there would have been HF, that would have been much more stronger because fluorine is more electronegative. The more the charge developed, the more stronger will be the bond. Got it? Got it, guys? Any doubt? No doubt now? So now I'm moving ahead. What are the conditions for hydrogen bonding? So write down these conditions. These are very important. How will you determine that where hydrogen bonding will take place? First of all, as name suggests, there should be at least one hydrogen atom because its name is hydrogen bonding. Obviously, there should be at least one hydrogen atom. That hydrogen should be attached to some higher electronegative element like these. So there should be one hydrogen atom and that hydrogen should be connected to either HO, HF, HN or HCl, right? This is the condition. Higher the electronegative element should have at least one lone pair of electron. So oxygen, fluorine or nitrogen, yes, I'm talking about not just these three. So whenever hydrogen bonding will take place, there will be hydrogen and one more element, and that second element should have a lone pair of electron. Lone pair of electron. So note it down. So this is the condition for hydrogen bonding. Note it down. There should be at least one hydrogen atom. That hydrogen should be connected to either of these one, and then the higher electronegative element should have one lone pair, at least one lone pair. If there are more than one lone pair, then that is good. But there should be at least one lone pair of electrons. Got it? There should be at least one lone pair of electrons. Any doubt? So now you know the hydrogen bonding. So here I'm showing you delta negative. So this is the hydrogen bond. Delta positive, right? So this hydrogen is connected to nitrogen. Similarly, if you are taking OH, delta negative, delta positive, and this delta positive is combining with NO or F. This is N minus actually. It will go to, yes, superscript. Got it? So now conditions of hydrogen are clear. One should be hydrogen, chlorine, oxygen, nitrogen, and chlorine. One atom should be this. And now what is the third condition? What is the third condition? Can you tell me now? Anyone? Chlorine, oxygen, nitrogen, and chlorine. Third condition was that the more electronegative element should have lone pair. Okay, note it down. That's important. Is that done? So now you know the conditions for hydrogen bonding and you know what is hydrogen bonding. So can you explain me why HF is zigzag? Because if I'm making one HF, it could have been like this. Okay, but this is not like it. Actually, the structure of HF is like it. Just a minute. The structure is like fluorine, hydrogen, then we have fluorine. So, is there anyone who can tell me this that why this structure is zigzag? Yes, Tharian, can you tell me why this structure is zigzag? Be vast. What kind of repulsions are there you are talking about? Actually, this is not like it, and this one is right. Why HF is zigzag? No, Tharian, no. Actually, now I will tell you. These fluorines will also have lone pair, right? These fluorines will also have lone pair, and if you are arranging them like it, then lone pair will be like it, but now they are at 180 degree, so that the distance between their lone pairs can be maximum. That's why you arrange them in zigzag pattern. Got it? Yes, Therian, I hope now you got it. So why do you arrange them in this pattern? You arrange them in this pattern so that their electrons are at high distance. Why? In order to minimize the repulsion. Got it? Yes, I think this is not visible. So it is 180 degree I have written down here. I think now it is visible. Got it? Tell me now. So this will be the structure to keep lone pair at 180 degree. Yes, Akash, got it. So now let's move So guys, keep on liking this lecture if you are really learning anything from it. So keep on liking it and sharing it. So now I'm moving. Why density of water is more than ice? Why density of water is more than ice? Can you tell me? Normally solids have high density than liquid and then gas, right? But ice, yes, if you might have seen it, suppose this is water, then ice floats on it. Then ice floats on it. Got it? Why? Because ice is floating, so ice must have low density. Here, let me tell you, this is one water molecule. It is having two lone pairs, right? So what will it do? So through those two lone pairs, yes, it will make hydrogen bonding with others, and it will make a cage-like structure. Now I will show you. Yes, here you can easily observe. This is O, this is H, this is H, right? And this H is making hydrogen bond with another O. So how can I show you this? Yes, got it. And this O, if you can look at it, this O is making hydrogen bond with another molecule. So how will you draw this? Okay, let me erase it. Because once I make it with my hand, then it will be more clear. So this O is again making H, O, H, H, O, H. So guys, can you tell me? Yes, one single molecule, how many hydrogen bonds it is making? One single molecule. Yes, IT geek. My plus code is Rahul Cam. You can apply it. Yes, my plus code is Rahul Cam. So can you tell me how many hydrogen bond it is making? 1, 2, 3, and 4. Got it? So it is making 1, 2, 3, and 4. So one molecule is making 4 hydrogen bonds. Just observe it. Got it? Any doubt? So guys, when it will make like it, so a cage like structure will be formed. It will go and on and on and on. So a cage like, so when we are making a cage like structure, there will be vacant spaces, right? There will be vacant spaces here. So this is the structure of ice. So if we have vacant space, so the density is mass by volume. So the volume will be high. And if volume is high, so the density will be low. If volume is high, then the density will be low. And if density is low, so this is one of the reason. So the ice having cage-like structure, and that cage-like structure is having void, and due to those voids, it occupies large volume. And due to that large volume, yes, let me tell you, due to that large volume, it will occupy high space. It will occupy high space, and if space is high, so the density will be less. So guys, now it is clear. Yes, why ice floats over water. Okay, just note it down. Yes, Akash, Tharian, IT geek, anyone. Just note it down and keep on liking it. Yes. So every water molecule is making 4 hydrogen bonds. And I have shown you all those. So these dots. Yes, these dots are those bonds. Akash, I think now you can see. Yes, Akash Rajput. Just count them 1, 2, 3, and 4. You got it? So, due to this case-like structure, it will occupy the large volume. And once volume is high, so the density will be low. Got it? So, ice is having case-like structure. So, due to the voids, and when ice melt, then we have this linear structure. So, what kind of structure is it? Like this. And now two water molecules are joined by hydrogen bond, this blue color, right? So in this case, if you observe, one water molecule is making 2 hydrogen bond. One water molecule is making 2 hydrogen bond. So what I want to tell here, if you arrange them, yes, it will be like this, chain like. So initially we have cage like, that was in ice, and now we have the chain like, that is in water. So the density will be mass by volume. So here we have no voids, so the volume will be low and density will be relatively high. So when you are melting the ice up to 4 degrees Celsius, these chain-like structure will be formed. These chain-like structures will be formed. And once you are making these chain-like structures, yes, what will happen? They will occupy the less volume. And when they occupying the less volume, density will be high. So density of water will be greater than density of ice. 4 डिग्री सेल्सियस तक ये कहानी चलती रहेगी, right? Why? Because you are breaking. Initially one water molecule was making 4 hydrogen bond. Now the one water molecule is making 2 hydrogen bond, right? And if you further increase the temperature, what will happen? Now all these bonds are broken, and they will be random. And that's why we say that density of water is maximum at 4 degrees Celsius. Why? So can you tell me? Because in chain like structure the packing is efficient, but if you further increase the temperature, now what will happen? If you further increase the temperature, the thing that will happen is that all hydrogen molecules will be independent of each other and they will move in random directions. And once they are moving in random directions, guys, yes, again their volume will increase and density will decrease. So density of water is maximum at 4 degrees Celsius. I hope now you got it. Got it, guys? Any doubt, please let me know. No doubt now. So let's move now. Yes. HF hydrogen bond is stronger than HO. Still the boiling point of water is higher than HF. Is there anyone who can give me the answer? Yes, tell me. HF hydrogen bond is stronger than HO. Is there anyone who can give me answer to for this question? Yes, Akash, Tharian, anyone? Because we have already done this and this. Which bond will be stronger? This is 1. This is 2. So which bond will be stronger? 1 or 2? 1 is stronger strength wise. And if 1 is stronger, then to vaporize it, I have to provide more energy for HF, but this is not the case. In case of H2, I have to provide more energy. So is there anyone who can tell me the answer? When I'm talking about the water. So the answer lies in water. There are more number of hydrogen bonds per molecule. If you compare the hydrogen bond in water, yes, there are more number of hydrogen bonds per molecule as compared to HF. Got it? In water, there are more number of hydrogen bonds per molecule. Any doubt? So that's why, although the HF bond is stronger, but still boiling point of water is higher than the HF. Okay. So now let's move to the next point. The types of hydrogen bond. So we divide the hydrogen bond into two parts: intermolecular and intramolecular. And inter we further divide them into homo-inter and hetero-intramolecular. Right? It is inter. So this is intra. So intra, you might have seen intra means within, and enter, international, between two nations, inter school quiz competition between two schools, right? So when I'm talking about the intra means within. Intra means within. So it is homo intermolecular, it is hetero intermolecular, right? So the types of hydrogen bonds, so there are two types of hydrogen bond. It is intermolecular and it is intramolecular. So homo intermolecular and hetero intermolecular. So now I will discuss. So first of all, you should know about the difference between inter and intra. So inter means between two molecules. Intra means within the same molecule. If hydrogen bond is present within the same molecule, then it will be called intra. And if it is between two different molecules, like one water molecule, another water molecule, then I will call it inter. And if it is within the same, suppose like this, so then I will call it intra. Now you know the reason, because hydrogen bonding is taking place within the same molecule. No second molecule is involved in it. Got it? So now let's move. If I talk about the homo intermolecular hydrogen bond, so hydrogen bond between the molecule of same compound. So if it is between H2 and H2, then I will call it homo. If it is between ethyl alcohol and ethyl alcohol, then I will call it homo. So what is hetero? So now I will tell you the hetero. If it is between ammonia and water, then it is called hetero intermolecular. But the point is, yes, in 1 and 2, which one is correct? Can you tell me? Will the hydrogen bonding take place between NH or OH? Is there anyone who can tell me the answer to this question? This is 1, this is 2. Sorry, this is 2. Which kind of hydrogen bonding will take place? Will it take place between NH or between HO? Can you tell me? Can you tell me, guys? Anyone? So which is correct bonding? No answers. So in this case, it will be having delta minus, delta minus, delta minus. So guys, we know that everything is moving towards stability, everything. So when everything is moving towards stability, so it tries to release the energy, and energy will be released when the attraction is maximum. More the attraction, more the energy release. So how will you determine the magnitude of attraction? A q1 q2 by r square. So the charge, in which case the charge difference or the charge developed will be more. Here this is the hydrogen connected to O. Here this is the hydrogen connected to N. So in which case more charge will be developed, partial positive charge, that will be developed over this hydrogen. And if it is developed over this hydrogen, then I can say this one. Got it? So out of 1 and 2, which one is correct bonding? Now you know the answer. Got it? So let's move now. So now you know the intermolecular and intramolecular. Intra, it is left. Homo intermolecular and hetero intermolecular. Now what is this? This is boric acid. So boric acid H3BO3 or BOH full thrice. So each one of you should remember its structure. How will you draw it? How will you draw it? So here I am telling you, suppose I am taking one boron, O, 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 right? So this is 1H, this is 1H, this is 1H. Now here I am taking one more boron, O, O, and O. Now H, H, and H. Why I am making it? Because you will realize once I am again drawing another structure B, O, H, and it will be O, H, O, H. So what I want to tell you here, the point is that this O, this O, just a minute. We have this O, it will be making hydrogen bond with it. And then we have this hydrogen, it will be making hydrogen bonded. You can see here. You can see here. Got it? Similarly, in this case, this hydrogen will be here only. So why I am telling you, yes, this is a boric structure, and due to intermolecular hydrogen bonding. Why it is intermolecular? Because all molecules are same. Why do we call it intermolecular? Because all molecules are H3BO3. All molecules are same. And if I'm talking about it, yes, this is the boric structure, and it looks like planar structure. It looks like planar structure. Got it? So now you can observe it. Now this is also a case of intermolecular hydrogen bonding. Hetero is done, homo is done. So hetero intermolecular, there is one more case. Hydrogen bond between molecule of different compound. So here we have alcohol, here we have water, again alcohol. So it is between alcohol, water, alcohol, water, alcohol, water. Got it? So now you understand what is heteromolecular. Now what is intramolecular? So intra means within. So if hydrogen bonding take place within the same molecule, then I will call it intramolecular. Like if I take case of ortho, in case of ortho we have, this OH and we have chlorine. Now this chlorine will combine with it. This is having partial positive. This is having negative. So this is making it. So this is ortho, and you know that this is para. So in para it is having a large difference. It cannot make intramolecular. This is meta. Again in meta it cannot make hydrogen bond with it. So in order to have hydrogen bonding, if it is taking place for a hydrogen substituted, benzene or benzene substituted compound, then it is possible only in the ortho, because meta and para those can make hydrogen bond with other molecule, right? But not within the same molecule. So intermolecular is possible between meta and para, but ortho is possible in intra. Intra is possible in the ortho. Got it? So what are the conditions for intramolecular hydrogen bonding? What are the conditions? First of all, the ring formed as a result of hydrogen bonding should be planar. What kind of ring is this? So the ring, this ring that is being formed should be planar. Got it? Second point, 5 or 6 member ring should be formed, because if ring is less than 5 member ring, it will not be stable. Angle strain will be very high. Angle strain will be very high, so that ring will not be stable anymore. Third point, interacting atoms should be placed in such a way that there is minimum strain during the ring closure. So minimum ring, there is minimum strain means the bond angle should be as close to as 109 degree. That's why I told you that 5 membered ring is not stable. Got it? So these are the conditions for intramolecular hydrogen bonding. Effect of intramolecular, what are those effects? So in intramolecular, what will happen? Now suppose intramolecular hydrogen bonding is taking place in this, and it is dissolved in the water, right? Now this molecule will not interact properly with the water, because its hydrogen is already combined with the chlorine, so it will not dissolve properly in the water. However, in case of meta and para, there will be hydrogen bonding between this para product and water. So due to this hydrogen bonding, the solubility will be high. So due to intramolecular bond, yes, bond dissociation with the solvent will be less evaporated. So just a minute, I will take up your question. In case of ortho, I've told you the solubility will be decreased due to intramolecular. And there is one more point, because it is not properly solvated with the solvent. In this case, it is properly combining with the solvent, but in this case, it is not properly combining with the solvent. So what will happen here? What will happen? So in this case, yes, in case of ortho, due to intramolecular hydrogen bonding, association with the solvent is less. As a result, they can be easily evaporated. It means they will have low boiling point, because they can be easily evaporated. Got it? Next point, in case of hydrogen bonding of meta and para, there is intermolecular hydrogen bonding. So meta and para, what I was telling you already. Yes, they are forming intermolecular. So they are properly combined with the solvent. So it will be difficult to evaporate them. So their boiling point will be high. But ortho will have lower boiling point. Got it? Now next point. There will be higher association between the solvent molecule and given molecule. Thus I have to provide very high amount of energy to evaporate. So in case of intermolecular, boiling point will be high. Why? Because they are properly associated with the solvent particles and it is very difficult to evaporate them. Got it? But in case of intramolecular bond, boiling point will be low. Why it will be low? Now you know the reason. Because they are not properly solvated. Got it? So due to intramolecular hydrogen bonding, following properties will be less. Just remove it. Following properties will be less. And what are those properties? Tell me. What are those properties? Property number one, boiling point will be less. I have just explained you. Again, melting point will be less. Viscosity will be less. Can you tell me what do you mean by viscosity? It is the friction in liquids. If you take example of honey and if you take example of water, right? So what will happen? In honey, or if you take jam, or if you take sauce, tomato sauce, right? So their viscosity is very high. So viscosity is basically the kind of friction in the liquids between the layers. So one layer will not allow other layer to move ahead because there is very high friction between them. In water it is very low, in alcohol it is very low. So first of all you should understand what do you mean by viscosity. Then I will tell you that how viscosity will affect. So due to intramolecular bonding, viscosity will be low, solubility will also be low. So why viscosity is low? So if I'm taking suppose CH3OH, I'm taking suppose CH2OH, I'm taking here, got it? Yes. So in this case we have 3 OH. In this case we have 3 OH. So can you tell me in which case the viscosity will be higher? Anyone? First, second or third? So now I will tell you that viscosity will be higher because it will form hydrogen bonding and there are 3 OH. There are 3 OH. Okay. So single molecule is forming 3 hydrogen bond. So it will be a very dense liquid because it is properly mixing with the solvent. So viscosity of this will be high. So viscosity increases due to intermolecular hydrogen bonding between solute and solvent. Right? Viscosity increases due to intermolecular hydrogen bonding between solute and solvent. Got it? So if there is intramolecular hydrogen bonding, then again due to that intramolecular hydrogen bonding, that particular compound will not be able to form intermolecular hydrogen bond with the solvent. As a result, what will happen? Tell me guys, what will happen? So viscosity will be low. viscosity will be low. I hope now you got it. So let's answer some questions now. Acetylene will not form hydrogen bonding with the other molecule of acetylene. Why? Acetylene will not form hydrogen bonding with the other molecule of acetylene. So what is acetylene? So in this case it is Sp. So 50% S. So electronegativity of carbon is very high. Why? Because S character is more. And if S character is more, the electronegativity of carbon is very high. So how will it happen? Can you tell me now? Anyone? So now I'm telling you guys, if I take another molecule, suppose yes, this is acetylene. So why there is no hydrogen bonding between this? Why there is no hydrogen bonding? Is there anyone who can tell me? If I'm telling you yes, there is, this carbon is very much electronegative, but still there is no hydrogen bonding. So can you tell me, guys? Anyone? What is the reason? So the reason behind it, I'm telling you, what were the three conditions? One atom should be hydrogen, another should be fluorine, chlorine, nitrogen or oxygen, and here it is carbon. But carbon can also make, because here electronegativity of carbon is very high, so it's okay. And then there was a third condition that says that higher electronegative element should have a lone pair of electron. Okay, so in this case, this carbon is having no lone pair of electron. In this case, guys, this carbon is having no lone pair of electron. Got it? So this carbon is having no lone pair of electron. That's why it cannot form hydrogen bond. Any doubt? Any doubt? Please let me know now. No doubt? Okay. So acetylene will form hydrogen bond with O minus and N minus. Now can you tell me why? Can you tell me why? Any answers? Because currently whatever I have taught you, I'm using only that. Acetylene can form. So what is the reason behind it? What is the reason behind it? Tell me. So if I talk about acetylene, this is acetylene. Here this is having delta positive, here this is having delta negative. Sorry, reverse. Delta positive, delta negative. So it will be a linear structure. First of all, let me tell you. So let's draw linear here. Let me draw that linear. This is H. This is delta negative, this is delta positive. Now O minus. Again, this is having lone pair. So it can make hydrogen bond with O minus or N minus, but it cannot make hydrogen with another molecule of acetylene, because in that case carbon is having no lone pair, and without lone pair that is not possible. Got it? Now D2O sinks in water, whereas H2O does not. So D2O is sinking in the water. Suppose this is water. This is H2O, the blue color. Let me make the D2O red color just to distinguish that. So D2O is sinking in the water, but H2O is not, ice is not. Why? So it is having low density and it is having high density. So what is the reason behind it? What is the cause of low density of ice? Can you tell me now? Yes, I just explained you in today's class. Yes, ice is having cage like three-dimensional structure which is having voids or vacant space, and in order to have those voids that will occupy the large volume, so density will be low. What is density? It will be mass by volume. So density will be low because volume is high. In this case, yes, the hydrogen bonding in D2O is not so much extensive. So the density of D2O is high, and because of the high density, it will sink. Got it? Any doubt now? So the next question, HCl, HBr and HI all are gas, while HF is liquid. Why? So these are hydra acids. We call them hydra acids. These are gases. So generally when you prepare HCl aqueous, so this is water and you pass HCl gas to get H plus aqueous and chloride aqueous. So these are gases, but HF is liquid. Why? Can you tell me, guys? What is the reason behind it? Any reason, any logic? Again, I will tell you. In case of HF, yes, they are gas. HF is liquid. First of all, it is liquid. And in liquid molecule, why something is liquid? Anything is liquid because the particles of liquid is having higher attraction. And due to higher attraction, they are close to each other. And if they are close to each other, that due to high attraction, there must be some kind of forces. And because today's topic is hydrogen bonding, so now you know that in HF we have hydrogen bonding. In HF we have hydrogen bonding. And if this is hydrogen bonding, so what will happen? Due to this hydrogen bonding, yes, HF molecules are held together by relatively stronger forces. No such hydrogen bonding is possible in HCl, HBr and HI. So they are gas and HF is liquid at room temperature. Got it? So let's move now. So if I talk about the malic acid, this is stronger than the fumaric acid. So what is malic acid and what is fumaric acid? Can you tell me? What is malic acid and what is fumaric acid? Anyone? So malic acid is stronger than the fumaric acid. What could be the reason? This is malic acid. So both are towards the same side. So this is cis. This is transform. So in cis, what will happen? after losing one H, it will form O minus, and that O minus can form hydrogen bonding, right? And this is stable. In fumaric, they cannot form hydrogen bonding because the distance between them is too high. Got it? So everything is moving towards the stability, and if the product formed is stable, so more and more product will be formed, and during formation of this product, H plus will be removed, and more H plus are being formed, and you will say it is more acidic. You will say it is more acidic. So what I'm saying you, what I'm asking you, that again read the question. Malic acid is stronger. Why it is stronger? So you know the reason, because of intramolecular hydrogen bonding. The conjugate base formed is stable due to intramolecular hydrogen bonding, but no intramolecular hydrogen bonding is possible in this case. So I will say that malic acid is more acidic. So more and more H plus will be removed. Next question. Now can you explain that tetramethylammonium hydroxide is stronger base than that of trimethylammonium hydroxide? So tetramethylammonium hydroxide, what is that? Tetramethyl is a stronger base than the trimethyl ammonium hydroxide. So let's discuss this. First of all, draw the structure. H3C, it will be plus OH minus. And in trimethyl, got it? Now, yes. So in trimethyl compound, the OH group hydrogen is bonding to MENH. Got it? So this OH is bonded to this H, H connected to this, and there is hydrogen bonding, right? But in this case, this OH is free. So here it becomes difficult to remove it, but here it is almost free. So what does it says? Again read it. Tetramethylammonium hydroxide is a stronger base. So when we are talking about, just a minute. H and we have OH. So in this case we have hydrogen bonding. Just a minute. In this case we have hydrogen bonding, and it is very difficult to remove this OH. But in this case, guys, we have separate OH minus, and it is easier to remove this one. So this will be more basic. So tetramethyl ammonium hydroxide is a stronger base than the trimethyl ammonium hydroxide. Got it? Now I hope you got your answer. So I will take up this question, and there are so many other questions which I'm going to take in the next class. So guys, today time is up, so I cannot move ahead now. So if you really like today's class, then please share it and like it and click on the bell icon so that you can get latest notification of our lecture. Okay guys, just click on the bell icon. Once you are clicking on the bell icon, yes, we are also there on the Telegram app, and the link for our Telegram channel is given in the description part of this video. You can click over the description part and you can join our Telegram channel. So there are simple steps how you can join the Plus program. Just go to Play Store or App Store, download Unacademy's learning app and install it. And after installing it, yes, you just have to click on the plus. Once you click on the plus, you will be directed to this page where you have to choose your goal. Suppose you have chosen IIT JEE as your goal, then just click on the subscription button. So once you are clicking on the subscription button, yes, apply my code, that is Rahul game. And what will be the advantage of this code? Now I will tell you. For 1 year the fees is 38,000. For 2 years the fees is 56,000. But if you are applying my code Rahul game, then instead of 38,000 you just have to pay 34,000, and instead of 56,000 you just have to pay 50,000. Got it? Any doubt? So guys, just apply this code, and once you are getting this code, once you are applying it, you will be getting this discount. And on the plus, your course will be purely structured. Yes, you will have DPPs there, you will have modules there, you will have live quizzes, and along with live quizzes, every fourth class will be doubt clearing session. So there are so many things which you can get there. So if you are joining it, apply this code. This is my code, and you will be getting a discount of 10% using this code. So remember this code guys, and I hope you are doing well. So take care of you, and again I will meet you tomorrow in the next session, the session which I'm taking, that is rapid revision course for 2021.